Good day to all of you. Today we shall study about binary search tree. Firstly, our sincere thanks and acknowledgement to authors Ellis Horowitz, Sartaj Sani and Susan Anderson Freed, the authors of the textbook with title being Fundamentals of Data Structures in C. The content of the discussion I have taken from this textbook. This topic is studied under the subject Data Structures and Applications with subject code BCS304 from 3rd sem students of CS and allied branches in BA degree course. So first we shall know what is data structure. Already this I have discussed in my previous videos. You can refer to that. Just to recall, tree is a hierarchical data structure. It represents and organizes data in parent-child relationship. So the examples being folder structure, file system and tag structure in HTML. So what is tree? Tree is a non-linear data structure which organizes data in hierarchical manner. So it's a collection of data. So data in memory, that is called as node. So many data means in many memory locations they are stored. These memory locations are linked to one another and that forms a tree data structure. What is binary tree? In a tree, if any node if you take, so all the nodes, if they have to the max 2 children, means a node may have 0 child or 1 child or 2 children, then that kind of tree is called as binary tree. What is binary search tree? First it is a tree, then it is a binary tree. So it is a tree means the data is stored in parent-child relationship manner. Then secondly, it's a binary tree means any node if we take it will have to the max 2 children, means either 0 child, 1 child or 2 children. So hence it is a binary tree. Then why it is called binary search tree? Because the data elements will be stored in some sorted manner. So why hierarchical structure is used? It is efficient for searching, insertion and deletion operations on the data stored in the tree. So here the figure shows binary search tree. Why it is a binary search tree here? There if 8 if you take left side smaller than this, right side it will be greater. So left side of 3 is 1 which is smaller, right side 6 that is greater than 3. If you observe this, left side of that 4 which is smaller than that, 7 is greater than 6. So 10 if you take right side is greater, that is 14. 13 if you take, it is left side of 14 and it is smaller. So this rule, what is the rule here? Left child value is smaller than the root, right child value is bigger than root. So this rule is followed in storing the elements in binary search tree. Okay. So example for binary search tree, if you take, this is another example. So if we start from root here, 40, 30 is smaller than 40, hence left side. 25 is smaller than 30, hence it is the left child of 30. But 35 is greater than 30, hence it becomes right child of 30. 50 is greater than 40, hence it is right child of 40. 45 is smaller than 50, hence it is the left child of 50. 60 is greater than 50, hence it is the right child of 50. So this rule is followed here. Left child is smaller than root, right child is greater than root. So this is an example for binary search tree. So another, if you take, this is not binary search tree. First one is binary search tree. Second one is not a binary search tree because it violates the rule. Here 55 if you take, it is right side of 30. Of course it is greater, but it is coming on left side of 40. So this is left subtree of 40. So 55 is coming in left subtree of 40. Hence this violates the rule. So this is not binary search tree. Okay. What are the advantages of binary search tree? So with binary search tree, searching for an element in the tree is very easy. When compared to array and linked list, insertion deletion operations are faster in binary search tree. Next, we shall study how to construct binary search tree if data elements are given. Okay. Here the given data elements are 45, 15, 79, 90, 10, 55, 12, 20 and 50. The rule to be followed here are left child value should be smaller than root, right child value should be greater than root node value. So this rule has to be followed. So let us start constructing the binary search tree for this data. So first taking 45. So this node is having 45 value. Next comes 15. 15 is smaller than 45. So it should go to left child of this. Next 79. 79 is greater than 45. It should come as right child of this. 90 is greater than 79. It should be the right child of this. Next 10. 10 if you take in this tree created, it is smaller than 15, hence it should be left child of this root node 15. Then 55. 55 is greater than 45, so it should come right side of the 45. Okay, but right side we have 79, so 79 left side 55 it should come, hence 55 is on right subtree of 45, but it is as left child of 79. Next 12. 12 is greater than 10, hence it should be right child of root 10. Then 20. 20 is greater than 12, so it is right child of 12. Next 50. 50 is smaller than 55, hence it is left child of 55. So this is the answer for this. Okay, this is the binary search tree. Let us verify the answer. So this is the answer that we have got. Okay, this and what we have constructed both are one and the same. Now what is the advantage of binary search tree? Inorder traversal of binary search tree gives the elements in ascending order. So for inorder traversal, first we shall mark down arrow for each node. Now starting from here, if we traverse here, next left side, here it cuts red one, that is 10 we'll have to write. So then in this path, all after covering left, we are going to the right of 10, that is cutting, so 12. Next again rightmost, so it is cutting 20. So then if you go back to the root of this, then root of this, then it is cutting 15, then to the root of this, it is cutting 45. Then left, after traversing left side, we have to go for right side. Right side, its leftmost we should cover, then it cuts 50, then continue 55. So we'll have to cover all left. So now it is 79. After covering left side here, going right side, so it is cutting 90. So from right side back to root node. Procedure is over. Now if you observe here, inorder traversal of binary search tree gives the elements in ascending order. So that is the advantage of BST. If any key values or data elements are stored in memory in the binary search tree kind of data structure, that is storing and organizing the data in memory as binary search tree helps when in order traversal we take to that we get the elements in ascending order. Okay, so let us see another example. So to construct binary search tree, first we shall take 4. 2 is smaller than this, hence it becomes left child. 3 is greater than 2, hence it becomes right child of 2. 6 is greater than 4, it becomes right child of 4. 5 is smaller than 6, hence it becomes left child of 6. 7 is greater than 6, hence it becomes the right child of this. 1 is smaller than 2, hence it becomes a left child of 2. Now this is the binary search tree for the given example. If you verify the answer, this is what is we have got here. Okay. Next, in order traversal of this binary search tree if we take, we will get the elements in ascending order. That we shall verify now. For that, mark down arrows here for all the nodes. So for this, you can refer to my previous videos in which I have explained pre, in and post order traversal of a tree. Okay. Next, after marking, let us move from start. So all left side we should cover first. So going left, then its left side, then this red arrow is cut, so we shall write node 1. So if you continue after covering leftmost going to its root, so then 2 is cut, its red arrow. After covering left here, moving to the right of 2, then it is cutting 3, so it's red arrow. Then after covering right, so moving to its root, then moving to its root, then 4 is cut. So now moving to the right side of 4, then left side of 6, then 5 is cut. So after covering left side to the root, that is 6, so 6 is cut. Then moving to its right side, so then 7 is cut. Then coming back after covering right side to its root, after covering its right to the root of 6, that is 4, then the procedure is completed. Now if you observe these elements, they are in the increasing order. Okay, that is how when elements are given, we can construct binary search tree for this. After constructing in order traversal of that binary search tree, then we get the elements in ascending order. So what are the tree traversals and in order traversal that I have covered in my previous video? For that you can refer to them. Okay. I hope you understood what is a tree, binary tree, then binary search tree. Then how to construct binary search tree if data elements are given, and if in order traversal if we do for a binary search tree, how we get the elements in ascending order. I hope you understood. Thank you.